Shall we start, sir? Good evening, sir.
Good evening, madam.
Yes, sir.
Okay.
Okay, sir. Good evening to all. We have assembled here for the 4-day workshop on SPSS statistics from basic to advanced, organized by Aguman Foundation and Seva Academy. We welcome you all to the second day of this workshop. We are proud to introduce again Dr. Chaudhary sir from Gujarat to handle this session on exploratory data analysis. And the next session will be at 7:30 by our Paraksha sir on parametric hypothesis testing. The second session will be on parametric to handle this session. Okay, sir. Sir, shall we start, sir? Please start the session, sir.
Yes.
People
yes.
will be joining. Okay, sir.
Okay. 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 Good evening, all. Today's session is about exploratory data analysis, which is the first and the foremost important step after we prepare a data file. So, in any research, when we collect the data using questionnaire or secondary data, then we prepare a data file either in Excel or in other format like CSV format, TXT format, that is text format. And then if you are using SPSS, then we import that file into SPSS. So in yesterday's session, we have discussed about the importing the Excel file or CSV file. It is exactly same way. We can import the Excel file and the CSV file in SPSS. After importing the data file in SPSS, the next step is labeling the variables and assigning the value labels to the categorical variable and defining the type of measure for each variable, right? That we have discussed yesterday. If we have scale variable, that is interval or ratio type data, then we use the measure as a scale. If we have a nominal variable, then we use measure as a nominal. If we have ordinal, then we use measure as ordinal variable. Okay, so this is how we prepare a data file. Okay, so after preparing the data file, obviously the next step is how to analyze the data. So depending upon the research objectives, depending upon the research question, the next step is before applying any statistical test or any statistical methods, the first stage is always exploratory data analysis. What is the meaning of exploratory data analysis? So exploratory data analysis means exploring the data, whatever the data, all the variables, whatever the variables we have collected, whatever the data we have collected for all the respondents, right? So we try to explore. That means we try to understand the data, right? How we understand the data? There are two ways. So in exploratory data analysis, there are two techniques. One technique is the data visualization technique, or what we call it as a graphical presentation of the data. That means we try to visualize the data graphically so that we get idea about the data, about the trend in the data, about the pattern in the data, about the center of the data, and about the variation in the data. Okay, so the first step is always exploratory data analysis. In exploratory data analysis, the first part is visualization of data, and second part is numerical summary. That numerical summary is also known as descriptive statistics. right? So we visualize the data and then we try to summarize the data with the help of some descriptive measures, right? And again, as I told you yesterday, even Parag sir explained you the appropriate graph, appropriate technique we have to select based upon the type of variable, right? So depending upon the type of data, type of measurement scale, we have to select appropriate chart, appropriate graph. Okay. So same way, depending upon the type of data, we have to select the summary measures of the data. Okay. So today also we are using the same data file, right? So sorry. Just 1 minute. Okay. Okay. So in exploratory data analysis, we have, as I told you, it is a crucial part in every research project. So once we have a data, ready data, then the next step is explore the data. It is popularly known as EDA, right? It is popularly known as EDA, that is exploratory data analysis, right? So before applying any statistical testing techniques or model building or a regression analysis, we have to examine the data using graphs and summary statistics. That summary statistics is known as a descriptive statistics, right? So for this, we have this technique, that is EDA, right? Now, what this EDA gives you? It gives us idea about the unusual or typical values. Now, what do you mean by unusual values? So many times when we collect the data, so some of the observations are beyond the actual range of the data. That may be because of data entry error, or that may be because that observation is beyond the range. There may be possibility that the value is outside the range. Say for example, when we collect the data about height, okay, so generally we know the range of the data. Okay, exactly. Padma, exactly. That is known as a outlier. Okay. So to get idea about the outlier in the data, because outlier, if there are outliers in the data, then it will affect the analysis of the data. Okay. So that particular observation, one or more observations are unusual or typical, they are known as outlier. So we will discuss that how to trace out outlier in exploratory data analysis. Okay, so that is the first part. It gives you idea about the unusual observations or outlier. Then center of the data. If we are talking about numerical data, so in the numerical data, specifically when scale type data, whether it is interval or ratio type data, so we try to find out the center of the data. So there are three different measures for the central tendency, that is mean, median, and mode, right? So Parag sir already explained you about the use of which particular measure is used when we have different type of measurement, right? So it gives us idea about the center, mean, median, mode, right? So central value of the data, what we call it as a general word for mean, median, mode, that is average. Okay. So depending upon the type of measurement, we have to use appropriate measure, right? Similarly, we have spread of the data, which is also known as dispersion, or which is also known as a scatteredness of the data, right? How scattered your data is, how much dispersion, how much variation is there in the data. So that can be measured using variance, standard deviation. There are other also, that is interquartile range or quartile deviation, right? Uh, And it also gives us idea about the extreme values in the variable or in the data, like minimum and maximum value, right? So this is what exploratory data analysis gives us. Okay. Now, what is what are the different methods, right? So here already Parag sir explained you, but actually in today's session we are doing all this with the help of SPSS. right? Parag sir explain you when to use which chart, right? Today, based on the data, we have to use the appropriate chart in SPSS and how to do that. So there are some steps. So I will show you different steps, right? So these are the different charts or graphs: simple bar chart, multiple, which is also known as a cluster bar chart. Then we have a stack bar chart, right? Then we have pie chart, simple box and whisker plot, cluster box and whisker plot, then histogram and scatter plot. So these are the commonly used statistical graphs for visualization of data. There are other also for the advanced statistical analysis, right? But these are most commonly used graphs, right? What is simple bar chart? You know simple bar chart? It is specifically used when we have a categorical data. When we say categorical means either nominal or ordinal type data, then we can use simple bar chart, right? It is now this is all about the how it is plotted, right? So we have the plot consists of a group of equidistant rectangles, one for each group or category of the nominal and ordinal. The height of the rectangle represents the count in each category, right? Right? Count in each category. Suppose I have to draw the bar chart for male and female, right? So what is the height? So it shows the number of males, number of females, and width of the rectangle. That there is no meaning for the width. It is arbitrary, but it must be same for each rectangle. Okay, so this is about the simple bar chart, right? Now we will discuss all these visualization or exploratory tools using with the help of hard study data, right? So I have shared yesterday, we have discussed how to prepare the SPSS data file from Excel, right? So we have Excel data file for the same data, hard study. Then we convert that to hard study data.sav, that is a SPSS data file, right? So I have shared this data file with the madam, right? So actually try to understand this. Here you cannot open this data file in your desktop or laptop unless and until you have SPSS installed. Okay, because it is having the extension .sav, right? So it is specifically SPSS data file. Okay, so to open this data file, we need SPSS, right? So if you double click, if there is SPSS, so just double click on that file, it will be open in SPSS. Let me show you. So this is my data file, hard study data. So when I double click, so automatically it will open IBM SPSS, right? And it will open a data file, right? So this is my data file. Okay. At the same time, another window also opens, right? That window title is output one. Okay. So this is output window. Okay. And it is used to get the information about different sequence of commands used. So it gives you here the log file, right? And whatever the analysis, say for example, we are plotting a bar chart, right? So that bar chart appears in this particular window, right? So this is the output window. This is your data window, data file, data editor. Okay. And in data editor, as we have discussed in yesterday's session, there are two tabs. One is a data view, another is a variable view, right? So data view, it shows the data. In the variable view, it shows the information about the variables, name, right? Then the type, then the label and value labels. If we have nominal and ordinal, then we have the value labels. So this already we have discussed in yesterday's session, right? So this is how we can open the SPSS data file. Or the other way is, first open SPSS, go to file menu, click open, go to data and select your folder and appropriately select the file and just click open. So it will open that particular data file. Okay, so this is how we can open a data file. Okay, now once you open, now our first chart is a simple bar chart, right? Now there are two ways. Try to understand this. There are two ways to plot any chart, right? One is using the chart builder, right? So if you look at the menu, right? So we have file, edit, and so on. We have one menu, that is graphs. It is specifically devoted to only visualization, right? So first option is chart builder, and the last option is legacy dialogues, right? So usually we prefer this legacy dialog, right? Because it is very easy, right? In chart, we can also use chart builder. In chart builder, we have to drag and drop the variables on particular chart. Okay. So here we can click on graph, then legacy, and the first part, that is first command, first option, that is bar. Okay. So when we click here, that graphs, then legacy and bar, it will pop up a new window. It shows different options for the bar chart. Okay. So first one is a simple bar chart. Second one is a cluster bar chart. Third one is a stacked bar chart, right? Now, depending upon the type of bar chart, we have to select appropriately. If only one variable we have to represent, one categorical we have to represent, we use simple. If we have to represent two categorical variable, visualize two categorical variable, we can go for either cluster or stack, right? And here, summarize the group of cases, summarize of separate variables and values of the individual cases. So usually here, by default, the first option is available and we use that option. Okay. So for a simple bar chart, for a single variable, we use simple bar chart, right? Now, after that, we have to click on the define button. So when you click on the define button, so it will pop up another window, right? Here we have the another window. Sorry. Okay. We have the another window, and then we can go for, say, for example, I want to visualize the gender. Okay. I want to, sorry, education category, right? So depending upon, see, you can visualize gender also because it is categorical. You can visualize education level also, right? So just we have to select this education level along the category axis, along the x-axis, right? And these are for the advanced that we will see later. So if you want to panel the data graph, so you can use this option. Another variable use as a row panel, another variable is used as a column panel. Okay, so these are the options. And here we want to represent number of cases. If you want percentage of cases, select this option, right? Similarly, if you want to visualize the cumulative percentage, you can select this option. Okay. And this is the title, right? So usually I suggest the user always click all the options, all the buttons, so that you get idea. When I click here, okay, here I can give the title, I can give the subtitle, I can give the footnote. Okay. Similarly, if you click on the options, what are the options, right? So it will display all possible options, right? So this is how we can select the variable. Then in the title, click on the title to add the title, right? So here you can add the bar chart for education label. Okay. So this is how we can assign the title for the chart. Okay. Then the next part is, see how we can, this is how we can give the title, right? And then just click OK, right? So when you click OK, so in the output window, it will plot the bar chart. Okay. In the output window. Okay. Okay, Padma, what is the missing values, right? So many times what happens? So in your data, when we enter the data from the questionnaire, some of the respondent has not given any responses. Okay. Say for example, you have one column that is family income, right? So you have all the values, but few respondent has not given their family income. So in that case, what happens? So you cannot enter the value by your own. So we keep that value blank. Okay. And such a values are taken as the missing values because we don't have a data. Okay. So such a values are taken as a missing values, right? So this is how we can use the missing values. Okay. Now this is a bar chart. So look at this. along x-axis, this is a category axis. So we have the different labels for the variable education, right? And along the y-axis, we have the count, right? Because we have selected count, so it shows count, right? So if you do it again, say for example, graph, legacy, bar chart, right? So whatever the earlier we have selected, it is as it is. But right now, I don't want the number of cases, but I want percentage, right? So just click on the percentage of cases, click OK, and you can see the percentage along the y-axis. Okay, you can see the percentage along the y-axis. Okay, so this is how you can create a simple bar chart. Okay, if you want to edit the bar chart, so you can double click on the chart. Okay, you can double click on the chart, and here we have some additional option, right? You can change, annotate, you can add the grid lines, right? Say for example, look at this. You can add the grid lines. So, and once you close this, so it will show the grid lines, right? So these are some additional option. For this, you need to explore, right? So just double click on the chart. It will open the chart editor window. Okay, it will open a chart editor window, right? So this is how we can uh, create a bar chart, right? So similarly, suppose I want to visualize the bar chart, but that is for the, say for example, systolic blood pressure for the various weight status, right? Now try to understand systolic blood pressure. This is my data file. What is SBP? SBP, systolic blood pressure, that is a numeric variable. It is a numeric variable. And for numeric variable, you cannot create a bar chart, right? So whenever we have numeric variable, we can create histogram. Okay, but I want to visualize the systolic blood pressure along with the weight status with the help of bar chart, right? That means for the weight status, for the overweight, for the normal weight, for the underweight, right? I want to visualize that, right? How to do that? So just go to, again, graph, legacy, click on the bar, right? Again, select the simple, and here you can choose other statistics. Okay, you can choose other statistics, right? So let me show you. Okay, so this is how one. Okay, so graph, legacy, again bar chart, simple, click on define. Okay, now instead of education, what I want to visualize, weight status, right? In yesterday's session, we have given the label BMI category. It is up to the user, right? So in this file, I have given the label name, variable name, weight status. So based upon the BMI, we have different labels, right? Based upon the BMI, we have different status, weight status, right? So select, because this is a categorical. Okay, it is a categorical, right? So you can select it here, categorical. Now since I want to visualize the weight status along with the systolic blood pressure, right? That means I want to visualize systolic blood pressure for the overweight people, normal weight, underweight, right? So in that case, you can select other statistics. And here we can select systolic blood pressure variable here, right? So by default, it is mean. Okay, by default, it is mean. So what actually it will perform? It will calculate, because see, overweight. So there are some number of respondents are belonging to the category overweight. For all overweight, whatever the SBP we have, so it will calculate average systolic blood pressure for the overweight, average SBP for the normal weight. If you want to change the statistics, so click on the statistics, and here you can select median, mode, number of cases in each category, or standard deviation, and so on. So these are some additional. Okay, and then just simply click on the OK button. So now we have, now see what we have. See, try to understand the difference. In the first bar chart, we have, say for example, let us try to create a bar chart for that weight status only. Okay, so just remove this number of cases and for weight status. So see what we have. Underweight. So how many underweight respondents are there? How many respondents are belonging to the normal weight category, overweight category, and obese category? So along the y-axis we have count values. That means frequency in each category, right? But in this case, this is not a frequency. For underweight people, what is the average systolic blood pressure? Okay, so see, actually this I have to change this. What do we call it as a 1 minute? I repeat the calculations: graph, analysis, bar chart, simple, define, right, and then select systolic blood pressure here and change the title. Right now, it is not education level, so bar chart for weight status with SBP. Okay, bar chart with weight status with SBP. So look at this, right? So what it gives you? It gives you the average systolic blood pressure for the underweight respondent, for the normal weight respondent, for the overweight, and for the obese, right? So this is how we can create a bar chart showing the two variable. Okay, showing the two variables. One is a categorical, another is a scale variable, right? So there is alternate way also that we will discuss in subsequent uh, slides. Okay, so this is how we can create. Right now, many times we have to create a panel chart, right? Panel chart. What is a panel chart? So it is a comparative study of two or more categorical variable, right? Because simple bar is used for only one categorical. But I want to compare two categorical variables simultaneously, but panel wise, right? So what is the difference? So see, when two categorical variable you want to compare, you can use multiple bar chart or we can use stacked bar chart. So try to understand the difference between the multiple bar chart and bar chart with a panel. Okay, I will show you how to do that, right? So for example, education and gender. So I want to compare education level gender wise. Okay, I want to compare gender wise. So okay, so again go to graphs, legacy, bar, again simple, click on the define button. Okay, and then so see this legacy bar chart, right? Then define button, right? So generally what happens, so when we use the same command, so earlier variables are there. Okay, so there is one option to remove. Say for example, the title. Suppose I forgot right now in the previous chart, I forgot to change the title. Okay, so in that case, what happens? So to remove all this setting, we have here at the bottom one button that is a reset button. Okay, so look at this. There is a reset button. When we click on this reset button, it will clear all. Okay, it will clear all the previous option. Okay, now what I want to visualize, I want to visualize education level, right? And according to the gender. So here we can use a panel. Okay, so what is the difference? I will show you. Okay, so this is, say for example, panel, right? Now just click OK and you can see, right? So here the entire graph, so you get two simple bar chart, right? Why two? Because my gender has two levels, male and female. If there are three levels for the gender, then it will show you three panels. Why it is important? Because you can compare this within the same graph, right? Within the same graph, you can compare that how many respondents are having no education, female respondents are having no education, how many male respondents are having no education. Okay. Again, another important thing, because those who are familiar with Excel, in Excel, we can show the value labels. So just double click on this. So you will get a chart editor, right? You will get a chart editor and on the chart editor, we have this option, that is data label. Okay, so here you can click on each bar, right? So it shows the count values and just close down, right? Now it is comparative. So say for example, in male and female, almost equal number of respondents are having no education, right? Here, only 3 are having senior high school, 3 male, and 6 females are having senior high school. This is just a comparative, right? So this is how we can create a panel simple bar chart. Now, why we have row wise? Because I have selected row wise. So again, if you click to repeat the process, and instead of this in the row, suppose I select in the column and click OK. So I have side by side. Okay, I have side by side. Okay, so this is how we can create a panel simple bar chart in SPSS. Anytime, again I repeat, if you want to edit the chart, double click on the chart. It will open in the chart editor and simply apply certain editing tools and you can edit. Even you can change the colors of this bar also, right? These are the by default setup of SPSS. Okay, so this is how we can create the row panel as well as a column panel. Okay, now simple bar chart summarize of separate variable, right? I want to summarize a separate variable, right? Say for example, so I want to summarize a numerical variable by categorical, say blood glucose and systolic blood pressure by gender, right? So blood glucose is a numeric, systolic blood pressure is a numeric variable, but gender is a categorical. I want to compare the blood glucose level of a male respondent and female respondent, right? At the same time, SBP of male respondent and female respondent, right? Now, in this case, it shows the error bar chart. That is a 95% confidence interval, right? So it will calculate the mean blood glucose for male, for female, and then confidence interval 95% for male and female separately. Okay, so how to do this? So again, it is same thing. So go to graph, legacy, bar chart, define, sorry, just cancel this. Graph, legacy, bar chart. Okay, now here summarize summaries of a separate variables, simple bar chart, and then from this select the middle option, define. Okay, now what is a bar represent? So obviously that bar represents, what is a bar? So that bar represents the average values, right? And we have to panel by the gender, right? So what I can do, this blood glucose, then SBP. So as I told you in the previous, by default, the statistic is taken as mean, but you can change the statistic from here. Okay. And then I want to summarize these two numeric variable by gender, row wise or column wise. That means panel. Okay. When I click OK, you can see this. Okay, but right now there are no bars, error bars. It is simply the average, right? See, for gender, male and female, this is for blood glucose, this is for systolic blood pressure. Okay, but there are no errors. Why? Because I have not selected that option. Okay, so go to this and then options, and here you can select a display error bars. I repeat, go to options and then display error bars. So we have by default 95% confidence interval. Okay, so just click continue, click OK, and now we have this, right? So this is the center value. The center value is a mean. This is the lower limit for the confidence interval, upper limit for the confidence interval. That means that much is the error. Okay, so allowable error, right? So this is how we can create the error bar chart using these options. Okay, so these are the steps for this, right? Now the next step is cluster bar chart. or what we call it as a side by side, right? So this is about the cluster bar chart. In our usual terminology, we call it as a multiple bar chart. In SPSS, it is a cluster bar chart. Okay. So go to graph, legacy, again bar. Now this time select the cluster option. Okay. Cluster bar chart and summaries of group of cases. Define. Okay. Now since we have two categorical variable, right? We have two categorical variable. So you can select the categorical variable one by one, right? So first is the education level and gender. So I want to compare, right? I want to compare education level by gender. Okay. And then simply click on the OK button. Okay. So here there is a, sorry. Okay, so this is OK button. Now you can see we have the cluster bar chart or simply multiple bar chart. Okay, because we have selected first variable as a main variable, that is education level. So along the x-axis we have the education level, and at the same time we have the legend for showing two different bars. So blue is for male, green is for female. Okay, so this is how we can create the cluster bar chart. Okay, so similarly, you can create a stack bar chart. So go to legacy, bar, and instead of cluster, just select, okay, stack bar. Okay, and again select education level and stack by gender. Okay, and then click OK here. Okay, and now you can see the same bar chart, but now it is stacked. Okay, it is a stack bar chart. Okay, so this is how we can create a stack bar chart. Okay, now pie chart. So in yesterday's session, Parag sir already explained you. So when we have a categorical variable, either nominal or ordinal, we can go for either a pie chart or a bar chart, right? But uh, pie chart is usually used when we have limited number of labels for the categorical variable. This is a rule of thumb. Up to 5 and 6 level, it is okay. But if we have more than 6 or more than that number of labels, then it is very difficult to trace out in the circle particular slice, because suppose there are 12 labels for the categorical variable, right? So it is very difficult to trace out, right? That is why pie chart is used only for 5 to 6 levels of the categorical variable. Okay, so again go to graph, legacy, right? And here we have the fifth option, that is pie chart. Okay, so again you can select, say for example, education level as a this variable, define slice by, and click OK. So you can see this, right? Here also you can use the data labels. Okay, so these are the data labels. By double clicking on that chart, you can get the data labels, right? So click, so here it shows the data label, right? So this is how we can create a pie chart. Okay, so this is a pie chart. Okay, then same way we can create a panel pie chart, right? So again go to legacy, pie, right? Then define, right? And suppose I want a separate pie chart for male and female according to the education level. So you will get a separate pie chart. This is for male, this is for female. Because I have selected row, so it gives me the row wise panel. If I select column, it gives me the column wise panel, right? So if I select it here, it gives me the side by side pie chart, right? So this is how we can create a pie chart, panel wise pie chart. Okay, so this is all about the categorical variable. When we have a categorical variable, we can use simple bar chart, multiple bar chart, or cluster, stack bar chart, or pie chart, right? Now, suppose I have a numerical variable, right? I want to visualize a numerical variable. So, the most important chart, that is a box and whisker plot, okay? And it is a very, very important plot to visualize the numerical data. It gives you 5 number summary. What are the 5 numbers? For any numerical data, this is a popular name, 5 number summary, right? It is also known as a Tuckey's 5 number summary. Tuckey is the name of the scientist who gave this 5 number summary, right? So 5 number summary. What are the 5 numbers? First one is a minimum value. Second, that is a first quartile, median, third quartile, and the maximum value, right? Quartiles are the values which divides whole data into 4 equal parts. If I want to divide, I want to break a line into 4 equal parts, I have to cut the line at how many places? 3 places, right? I have to cut the line at 3 places. So, and all parts are equal, right? So, first part is, that is 25%. It is known as a Q1. Second part, second cut, that is Q2, which is also known as a median. And third cut, that is Q3, that is a third quartile, and maximum, right? So, these are the 5 number summary, right? And this box plot also based on this particular formula. It is known as a interquartile range. And this box plot is the easiest way to trace out the outliers in the data. Okay, we will see how to do this. So this is the actual box plot, right? Now try to understand the box plot. You can plot a box plot vertically or horizontally. Okay, so look at this. These circles, these dots are the outliers, right? They are beyond the range of the data. Now, how to find out the outliers? That we will see. Okay, if in a box plot, or if in that particular variable, if no outliers, then the end of the whisker, right? So this is the beginning of the whisker. This is the end of the whisker. Okay. So beginning of the whisker, that is the minimum value. End of the whisker, that is the maximum value if no outlier exists. But if outlier exists, then this is not the minimum and this is not the maximum. Okay, so these two lines are known as a whiskers. Okay, and inside that we have a box, right? So that is why it is known as box and whisker plot. Okay, now in the for this particular rectangle, this lower side of the rectangle, that is the Q1, that is a first quartile, right? That means below Q1 we have 25% of the data. That is why it is also known as 25th percentile. Okay. The middle line of the rectangle, that is either median, which is same as Q2, which is same as 50th percentile. Because below this line, we have 50% data, and above that line, we have 50% data. Exactly same way, you can interpret the third quartile also, right? Now, what are these values, right? So, if there exist outliers in the data, right? So, any software, whether you are using SPSS or any other software, the technique of tracing out the outlier is it will calculate Q1, Q2, Q3, right? And then it will calculate the interquartile range. What is that? Q3 minus Q1. Okay. So it will calculate this value, that is a Q1 minus 1.5 into IQR, right? So that is Q1 minus. So this is the value of Q1. And if you are subtracting something from that, so you are moving to the bottom, right? If you rotate this graph, this plot, and clockwise, so it is subtracting means moving to the left side. Okay. And if you are adding Q3 plus 1.5 IQR, so you are moving to the right side. Okay. So that means any observations which is below Q1 minus 1.5 into IQR, they are considered as the outlier. Okay. So this endpoint is Q1 minus 1.5 IQR, right? Exactly same way at the top, this endpoint is a Q3 plus 1.5 IQR. And any observation above that, they are known as outliers. Okay. So this is how we can understand the box plot. Okay. Another important thing is the size of the rectangle may vary depending upon the data, right? Right. You know the positively skewed, negatively skewed, right? So positively skewed and negatively skewed, right? So if you plot the graph curve, right? If it has a longer tail toward the right hand side, it is positively skewed. If the graph curve has a longer tail toward the left hand side, it is negatively skewed. But if there is no skewness, the data is exactly a bell-shaped symmetric curve, right? So if it is symmetric, then these two rectangles are exactly identical, right? If the data is not symmetric, this middle line moves either downward or upward. Okay, so this is how we can understand the box plot, right? Another important thing, if this median is towards this bottom side, right? That means that is the center of the data. Okay. If it is towards the upside, that is also the center of the data, but it gives you idea about the positive and negatively skewed. Okay. We will see with the help of example, right, how to draw the box plot, right? So again, click on the graphs, legacy dialogues, click on the box plot, right? Now there are two types of box plot, that is a simple and clustered. Simple box plot is used for a single variable. Okay, so let us see how we can visualize, right? So it is graph, legacy, box plot, simple box plot, define, right? And what we have selected, it is a serum cholesterol. Okay, serum cholesterol as a variable, right? Serum cholesterol as a variable, and we need a categorical variable, that is gender. Categorical variable gender. Okay, and then again we have the options, right? Actually here you can display the bar, but for that we have to select another way. Okay, but these options are not right now useful. Here you can also create panel wise. For say for example, I want to visualize the serum cholesterol gender wise and with respect to the smoking status, smoker and non-smoker. So you can select the row that smoking status in rows, right? Click OK. 1 minute. Yeah, exactly. Exactly. We can also test the normality of the data. I will show you that also in my subsequent slide. It is also there, right? So box plot is basically used for testing the normality, but what is the most important? The normality from the box plot cannot be trusted, right? The reason is uh, many times we have the data is not normal, but box plot shows that it is the whiskers are of equal size and middle line is very slightly near to the center, right? But we have the another way also, that is known as a QQ plot or normality plot. We will see that also. Okay. So see, when I have used this, okay. So see, when I have analyzed graph, legacy, box plot, simple, and I have used these options, right? Serum cholesterol as a category, a numerical variable, because box plot is for the numerical variable. Okay. So click OK, right? So actually it is repeated, no issue, right? Now first output is a case processing summary. right? So serum cholesterol is a main variable. Another variable is gender, which is categorical. So their labels are there. Valid observation, right? Summary of the data. So male 52, female 48. And this is a percentage. Okay, this is a percentage. Okay, and similarly, if there are some missing values, so it shows the missing values here, right? If suppose there are 5 missing values, so it shows the 5, and here accordingly it shows the percentage. Okay, so this is of that much not important. It is just to trace out if there are any missing values or not. Okay, so this is a case processing summary, and after that we have the 1 minute. Okay. Okay. After that, we have a box plot or box and whisker plot. You can see the box and whisker plot. Along x-axis, we have gender, the labels, male and female. Along y-axis, we have the numerical variable. Okay, numerical variable. Right. Now, what is the difference between the two box plot? You can see almost two box plots are more or less similar. That means serum cholesterol for male and female, the range and the symmetry is almost similar. But in a female, there is one observation which is outlier. And what is this 32? That 32 shows the position of serum cholesterol. Let us check, right? For the female, in the serum cholesterol column, 32th row. Okay, so let us see. This is my serum cholesterol, and this is my 32th row. Look at this, 382. So almost all the values are within the range of 200, right? And this one is 382. Okay, so there may be possibility of data entry error, or there may be possibility that that particular respondent SBP, sorry, serum cholesterol is very high. Okay, so that is why it is considered as outlier. Okay, so this is the minimum value, this is the maximum value, end of the whiskers. Okay, this is a Q1, Q2, Q3. But in case of the female, this is not the maximum value. It is Q3 plus 1.5 into interquartile range. So that is this value. And beyond that, any value that is outlier. Okay. Beyond that, any value is outlier. Okay. So this is how we can create a box and whisker plot. This is a case processing summary. See, this is how I have shown on the slide, right? This is the minimum Q1, median or Q2. This is Q3, and this is not maximum value. It is Q3 plus 1.5 IQR, and this is the outlier. Okay. So actually, for outlier, there is a separate technique whether to remove them or whether to replace them. So there is a separate research analysis for handling outliers. But for the usual practice, we either remove the outliers, right? For advanced research, it is removing the observations, removing the outliers. It is the loss of information. So we have the separate statistical technique. That technique is known as imputation. We replace the outlier by the average value of the entire data or median or any other measure, right? So there is a separate technique. Okay, so this is how we can create a box and whisker plot. Okay, so this is the same thing which I have explained earlier, right? Median, then whisker, smallest non-outlier, largest non-outlier, right? Okay, now cluster box plot, right? Cluster box plot, right? So in the cluster box plot, what we can do, we can we can create a box plot of a numerical variable, right? Of a numerical variable, say for example, serum cholesterol, right? And then as usual, gender, right? And cluster by smoking status, right? That means I have a separate for smoker and non-smoker, under male category, smoker and non-smoker under female category. Okay, so this is how we can define a cluster. I suggest try to explore the SPSS. If you really want to learn SPSS, just drag and drop some variables here and click OK and check, because there are many options and it is not possible to cover all the options in just 1.5 hours, right? So the purpose of this particular workshop is to ignite your mind, right? So once you understand the basic terminology, how to handle SPSS, you can understand the remaining thing just by practice. Okay. So click OK, and now you can see. So these are the cluster, right? Same here, it is for male and female separate box plot for serum cholesterol. Now in this case, again serum cholesterol, this is for male, this is for female. But since I have added third variable, that is smoking status, so we can have a side by side, that is multiple, or simply we call it as a clustered box plot. Okay, it is known as a clustered box plot. Okay, so actually this is for blood glucose, right? And we have created for serum cholesterol, right? So just try to understand where to use which variable. Recall the session of first session of the Paraksha, right? Where to use which variable? Numerical variable, when to use numerical variable, when to use categorical variable, right? So based on that, you can explore your data and you can analyze your data using statistical tools. In hypothesis testing also, in the regression also, when to use which variable, that is most important part for statistics, right? Okay, so this is how. Now histogram, right? Next part is histogram. So obviously we use histogram when we have to visualize a numerical data, single numerical data. You can combine with categorical also, I will show you that also, right? But when I have to visualize only single, right, numerical variable. Okay, so say for example, I want to visualize the serum cholesterol. So go to graph. Okay, so let me show you chart builder, right? Because already legacy we have seen. Okay, so chart builder, right? When we click on the, this is alternative way. See, in the gallery we have all the charts here. Okay, here we have all different type of charts. Okay, here we have the basic elements, right? Here we have the group and points and title and footnotes, right? But before that, what we have to do, say for example histogram. So what we have to do, so we have to click this histogram. See, it is mentioned here, drag a gallery chart here to use it at your starting point. So just drag, right? Or simply double click. Okay, either drag or simply double click. Okay, so here we can select the serum cholesterol, right? Serum cholesterol values along the x-axis, right? Along the x-axis. Along the y-axis, it will calculate the frequency. Okay, along the y-axis, it will calculate the frequency and then simply click OK. So this is your histogram for the serum cholesterol, right? Same graph we can create through the legacy histogram, right? And then serum cholesterol, right? And then simply click OK. See, we get the same graph. Okay, so more or less, except this value, because that is outlier. Okay, so except this value, more or less, most of the observations. So it has a bell like structure. It is not exactly symmetric, but we can see there are very few respondents having lower serum cholesterol. There are majority are having this within the range of 200 to 250, and there are very few having the high serum cholesterol. At the same time, for the serum cholesterol in the histogram, it shows the mean. Look at this. Mean serum cholesterol is 216.93. Standard deviation is 38.86 and total number of observations. This is just for uh, information. It gives you the information like this, right? Another important part is, see, when I use this legacy histogram, right? So there is a option display normal curve, right? So it will plot the histogram and superimpose a bell-shaped curve on the histogram. Superimpose a bell-shaped curve on the histogram. Exactly same way, you can go to legacy, histogram, right? And suppose I want to visualize serum cholesterol side by side, or say not side by side, row wise. That means panel. Okay. So for male, separate histogram, for female, separate histogram, right? Look at this. So we can visualize based upon the category. Because I have only two levels, it shows two. If there are more, it shows more histograms. Okay. Okay. Sir, can you please interpret standard deviation in this example? Okay. So actually, what is standard deviation? So standard deviation is nothing but the uh, variation present in the data, right? Variation present in the data. Let me give you a very simple example. Uh, okay, uh, just a minute. I will show you. Okay, so this is Excel spreadsheet because I don't have that writer. So I will show you very simple method how to understand this, right? Suppose I have uh, student 1, okay, and here I have student 2, okay, and there are 3 subjects, right? So that is subject 1, subject 2, and say subject 3, okay, and I want to calculate the mean, I want to calculate the variance, I want to calculate the standard deviation, right? I am taking randomly so that you get clear idea. Suppose the total score, the examination is of 30 marks, right? So this first student secure 25, 25 and 25, right? Second student secure, say for example, 20 in the first subject, 20 in the second subject, and 35 in the third subject, right? Now, can you tell me which student shows no variation and which student's data shows variation? Anyone? Yes, exactly. Student 1 data shows no variation, right? Why? Because the marks are consistent, right? Consistent mark, right? Say for example, if you calculate average, so in Excel we have the formula that is average. This is the data 25. Okay. Similarly, there is a formula variance. Okay. And this is the data, variation is 0. Okay. Similarly, we have standard deviation formula, right? This is my data. Okay. Now, when I copy this for the second student, see what is the difference. The average for both the student is exactly same. Their average performance is same, right? Yes. Okay. Their average performance is same. But if you compare the variability, so in the students 1 scores, there is no variation. Students 2 score, there is a variation, right? So actually, what is the formula for the variance, right? The formula for the variance is, let me show you. 1 minute. Because I don't have a writing pad, otherwise I will show you. But here, in my R Studio, I can write a formula. Will be opening. Yeah. Okay. So just a minute. Okay. So variance of x equal to this is the formula, right? Now what this formula gives you, right? So look at the formula. 1 upon n summation xi minus x bar square, right? So how the observations, what are the xi's? Observations. What is x bar? Center value of the data. How the observation, each observation vary from the center, deviate from the center, right? And this is the formula just to calculate squaring, because when we remove the square, this value becomes 0 for any data. Okay, that is a statistical result. Okay, so how xi's are deviating from the center of the data. Okay, and and if we take the under root of this, okay, if we take the under root of this, okay, so what is under root? So standard deviation of x, that is square root of this value. Okay, so it is square root of this value. Okay, so this standard deviation, it is just a measure to convert into a unit of the variable. Okay, so actually basically variance and standard deviation both are used to measure the variability, right? Both are used to measure the variability. When we use variance, suppose my variable x is weight, so the unit for the variance, say for example, just think about this. Suppose these are the weights, so here the unit is 0 kilogram, right? And suppose these are the weights, so it is 75 kilograms square, right? So to remove that unit or to convert that unit to a simple variables unit, so we take the under root of that. Okay, so see, when I use square root of this value, it gives me the same answer. Okay, so this is known as variation or standard deviation, right? So standard deviation or variance measures how the observations deviate from the center of the data, right? So if the observations are very close, okay, so let us take another situation. Okay, so here I am taking the same data and just I am changing the values. Okay, say for example, it is 24, 25, and say 26. See, because 24 and the average is 25, so this 24 is very near to 25. Their averages are same. All three are having same average. But what is variance? The variance is different. The standard deviation is different, right? So this is how, that means how the observations, 24, how much it is away from the mean, 25, how much it is away from this, how much it is away from this. So if the observations are away from the mean, so the variation far away from the mean, there is more variation. Okay. Otherwise, there is a less variation. I hope it is clear. Okay. Thank you. Thank you. Okay. So this is how we can, uh, 1 minute, we can create histogram. Okay. So this is side by side panel histogram. Okay. The next part is, you can change the color as I told you. You can change the color just by clicking on this, and from here there are different options available. You can change the color, right? So all the options are there. It is not possible to cover in 1.5 hour session. I am trying to explore the more, right? Okay, so this is how we can create the histogram. Okay, now panel histogram we have seen according to gender, right? So we have a separate histogram for male and female respondent for the serum cholesterol, right? Now scatter plot, right? So histogram is used for a single numerical variable. If you want to compare one numerical variable by categorical, panel wise, you can compare histogram or you can compare using box plot also. Okay. Now scatter plot is basically used when we have to find out the relationship between the two numeric variables, right? Two numeric variables, two or more numeric variables, right? So it is a graphical method of identifying the relationship between two numeric variables. Okay, so let us see. Uh, Again, go to analyze, legacy, scatter plot. There are different scatter plot. We have the matrix plot, we have overlay scattered, simple dot plot, and 3D scattered, right? So we will discuss the simple and matrix plot, right? So simple scatter plot. So we have to select the numeric variable. Say for example, weight, height. Okay, weight and height. You can choose the options. Actually, this is not applicable. You can choose appropriate title, right? And simply click OK, and you can see the scatter plot. Okay, so see what this scatter plot shows. What can you say about the relationship between the height and weight? If you look carefully, as you move from left to right along x-axis and bottom to top along y-axis, right? As height increases, weight also increases. It shows that there is a positive relationship between height and weight. Okay, so this scatter plot is useful in correlation and regression analysis, that is the last day's session. Okay, so this is how we can create a scatter plot, right? So if the points are along this side, that means as you move from left to right? That means height increases, weight also increases, right? So that is positive correlation, right? Suppose we have the reverse this way, right? Up diagonal. This is a diagonal. Okay. Principal diagonal. This is that means non-principal diagonal, right? From this mouse arrow, right? If the points are along this way, there is a negative correlation. Okay. So this is how we can create a box plot, sorry, a scatter plot. Okay. Now another I want to show you, that is scatter plot, matrix plot. Okay, so matrix plot. Even in the scatter plot, suppose I want to visualize for male and female separately, I can use this. So this is a box plot for, sorry, scatter plot for female about height and weight, for male about height and weight. Exactly same way we have another scatter plot, that is a matrix scatter plot, right? So basically matrix scatter plot is used
Sir? Sir?
Yeah. Sorry, madam. There is some network issue.
Okay, sir.
Okay. Okay. So this is how we can create what we were discussing. Okay. The scatter matrix plot, right? So actually scatter matrix plot is used when you want to compare more than two numeric variables. Say for example, I want to compare weight, height and age, right? Simultaneously, right? So it will create all possible scatter plot for all possible pairs. Okay. So look at this, right? So weight is compared with weight. So this one is blank that that diagonal, right? So here these are blank, right? So this one is age with weight, age with height, right? Height with weight, right? And this is weight with height and so on, right? So this is a matrix scatter plot. Okay. So many times we need to use a matrix scatter plot to identify the relationship between the number of variables. Say, for example, let us see in some other variables. Say, for example, this one, body mass index. Okay, so just remove the earlier one, and okay. So look at this, right? So this gives you idea about the relationship between different variables simultaneously. That is why it is known as a matrix scatter plot. Okay, it is known as a matrix scatter plot. Okay, now the next part is numerically. How numerically? So first part we have discussed data visualization, exploratory data, that is data visualization, right? Next part is numerical summary of the data, right? So numerical summary. So if we have the categorical data, so we can use frequency tables. We can create a frequency table, bar charts and pie chart. Okay. So frequencies for the categorical, right? Now see in SPSS, almost all the commands for the statistical analysis are available in analyze tab, right? Almost all the commands are available in analyze tab. Okay. So in the analysis, we have the second option, descriptive statistics, that is summary. Okay. So frequencies, right? You can choose the frequencies. Okay. And then if you want to create a table, frequency table, right? So you can select, say, for example, education category, right? And then at the same time, if you want chart also, so you can select bar chart, right? If you want frequencies on the chart or percentage on the chart, it is as per your selection and you will get the output like this, right? So see, this is a table, right? So these are the different levels of education, their corresponding frequencies. So out of 100 respondent, 26 are having no education, right? And this is a percentage because the total is 100, it shows the same value. Otherwise, it will calculate the percentage, right? And what is valid percentage? If there are some missing values, so it will eliminate the missing values and then count the valid percentage. At the same time, it will calculate the cumulative percentage also. That is 26 plus 31, 57, 57 plus 24, 81, like that. So it gives you the percentages also. So this is a frequency table for a simple single variable, right? So here, these are the options. You can select the chart. You can select the display frequency table. You can click on the this also the statistics also, but actually there is no because for the categorical variable, for the categorical variable, we cannot calculate mean, median. We can calculate mode, but we cannot calculate mean and median, right? So that is why this is not useful for that. Okay. So this is how we can create a frequency table. Okay. Uh, we have, this is a chart. Okay. Now descriptive statistic for one numerical variable, right? So when we have to summarize numerically one numerical variable, so for center, we can use mean, median, mode. For spread or dispersion, we can use range, variance, standard deviation, extreme values, minimum, maximum, and we have another, that is shape of the data, shape of the distribution, that is skewness and kurtosis. Okay. So here, let us see again. Let us see, that is analyze, descriptive, frequencies. Now instead of education, I can select weight, right? And statistics. So suppose I want mean, median, mode. I want skewness, right? Suppose I want quartile, standard deviation. So as per the requirement, we can select all these values, right? Chart. Now since it is a numerical data, I have to select histogram. You can choose show normal curve, continue, click OK, and this is a histogram, right? We have the summary statistics. Look at this. Valid observation 100, mean, weight, median weight, modal weight, standard deviation, and these are the Q1, Q2, Q3, right? But since for the numerical variable, so this particular table is of no use because it will count each values. Okay, it will count each individual values. And since we have more values, so here 47 occurs one time and so on. Okay, but this is how we can create a frequency distribution for the numerical variable. Okay, you can choose all these things, and this is a summary. Okay, now many numerical variable, more than one numerical variable, right? Say for example, I want to visualize, I want to create a frequency, right? So frequencies, then instead of weight, I want weight, height, and say for example, blood cholesterol, blood glucose. Okay, sorry, it is weight, height. Okay, now one more thing. If you want to select adjacent variable, you can use the shift key, right? But suppose I want to select non-adjacent. So select weight, height, and then hold the control key and select blood glucose, right? And then use this arrow key, right? So this is how we can select the non-adjacent values, right? Then from here, you can select different measures, right? You can select the charts and simply click OK. So see what we have. We have summary statistics for weight, height, and blood glucose, and frequency table, which is of no use here. And we have a histogram for weight, histogram for height, histogram for blood glucose. Okay. So this is how we can create a summary measures, descriptive statistics for more than one numerical variable. Okay, for more than one numerical variable, right? So descriptive statistics, right? As I told you, it is nothing but a numerical summary, mean, median, mode, standard deviation, variance, minimum, maximum. Because if you want to compare, say for example, I want to compare blood glucose for male and female. So I can compare minimum blood glucose for male and minimum for female, mean blood glucose for male, mean blood glucose for female. So from research point of view, we can compare this. Okay. So there is another way for the descriptives, right? That is, go to analyze, descriptive statistics, and instead of frequencies, you can go for the descriptives and select the variable, right? Now see, here it is mentioned variable or S, right? So you can select one or multiple variables. Okay. Here also we have the options. You can select mean, median. Sorry, not sorry, only mean is there. Okay, so you can use skewness, kurtosis, and then continue, right? And then click OK. So we have the summary statistics. Okay, this is the summary statistics for all the variables, weight, height, right, and so on. Okay, so this is how we can create a summary statistics. Okay, now another important thing. So standardized value. So you know standardized value. So suppose height is my data. I want to standardize this. So how can I standardize this? Right? So to standardize this, we can use a Z-score formula. What is Z-score formula? It is the value of the variable minus its mean divided by the standard deviation. Okay, so 161 minus average height divided by the standard deviation of height. Okay, so sorry, okay, instead of doing this, so this descriptive statistics gives you that also. Save the standardized value. So look at this. In my SPSS data file, we don't have this. We have the last column R weight. Okay. So when I select this standardized value, sorry, when I select the standardized values and save, click OK. So you can see this is R weight, sorry, Z weight, H weight, Z age, right? So Z is a standardized value, right? So all the values are converted to a standardized values, right? And the standardized values are basically within the range of 3.5 to minus 3.5 to plus 3.5, right? That is also known as the Z score values, okay? The Z-score values are easy to compare as compared to the actual values, right? So that is why we use the Z-score values, okay? So this is how we can get the summary statistics, okay? Now explore numerical data, okay? How can I explore the numerical data? So that is confidence interval, normality test, and normality plot. Now this is the most important part, right? So actually all the basic techniques are very, very important. But when we have to deal with hypothesis testing, when we have to deal with the numerical data, then we have to check the normality. So how we can explore the numerical data which provides descriptive statistics, confidence interval, normality test, and the normality plot. Okay. So here we have the option analyze, descriptive, and then explore. Analyze, descriptive, and explore. Let us check this. Analyze, descriptive, and explore. And here I can select, say for example, what I have selected, weight. Okay, so weight. Okay, if you want to divide it into different according to some category, you can do that also by taking a factor list here. Go to statistics. So descriptive statistics, right? Continue, and by default it is a 95% confidence interval. If you want 99, you can change this value, but by default it is 95%. Okay, you can use the plots also, right? You can use the plots also. So that is histogram, normality plot with test, right? Now this is the important option. Look at this. Go to plots, right? And then remove this stem and leaf, select histogram and normality plot with test. Okay, continue, right? And then in the option it is not required, right? And here at the end, display both statistics as well as plot. If you want only statistics, you can select this. If you want only plots, if you want both, okay, click OK and see what we have. 95% confidence interval for the weight variable. This is the average 64.22, average weight in kilogram. This is the lower bound. This is the upper bound. Then these are the trimmed mean. 5% lower and 5% upper data points are eliminated and the means are calculated. the actually trim mean is used when the data is not symmetric. Okay. Then median and all these values, right? At the same time, let me show you on the slide because it is slightly bigger. Okay, look at this. So normality test for weight variable. So there are two tests for normality. One is a Kolmogorov-Smirnov test, right? Normality means what? Whether your data is symmetric or not, exactly bell-shaped structure or not, or approximately symmetric or not. So that can be tested with the help of this normality. So Kolmogorov-Smirnov test, Shapiro-Wilk test. Basically, we prefer Shapiro-Wilk test, right? So here, this is the p-value of the test. Significance value, that is a p-value. Okay. If this p-value is greater than 5%, we say that the data is normally distributed. Look at this. If the p-value is not less than 5%, this is not less than 5%. Okay, so we say that this Kolmogorov syndrome, that is approximate test, right? It is a non-parametric test. So basically, we prefer this Shapiro-Wilk test. Okay, so it is for the testing the normality. Along with the numerical test, we have the QQ plot. QQ, that is a quantile, right? So here, these dots are the actual observation. This is a reference line. If the dots are very close to the reference line, data is normally distributed. If the dots are away from the reference line, data is not normally distributed, right? So this is just to check the again in detail, right? So I am not going into that. Okay, why normality is to be tested, Prashant? Okay, because in statistical theory, we have different kind of test. Okay, we have the t-test, right? We have chi-square test, we have z-test, we have ANOVA test, right? So in some tests are parametric test, some tests are non-parametric test, right? So for parametric test, like for t-test and z-test, if your data is normally distributed, then only we can apply the t-test. That is the assumption. Okay, assumptions of t-test. So in the subsequent session, Parag sir will explain in detail about that, right? But why normality is required? Because if we want to apply the t-test, right, we have to check the normality. If the data is normal, we can go for t-test. If the data is not normal for that particular variable, we have the alternative non-parametric test. Okay, so this is how we can. Okay, this is how we can. Okay, okay. So actually, normality is required if you are applying the parametric test. T-test is a parametric test. Z-test is a parametric test. Analysis of variance test is a parametric test, right? And in the theoretical derivation of all these tests, there is assumption. Assumption is the data is normal. Normal means exactly bell-shaped structure. Exactly bell-shaped. Say, for example, I want to compare from this 100 respondent, I want to compare whether the weight of the respondent, average weight of the respondent for the population is, say, for example, 55 kilogram or not. Okay. But if my weight data is not normal, I cannot apply t-test. I want to compare mean, but data is not normal. So I cannot apply t-test because for application of t-test, normality is required. Okay. So if normal data is not normal, we cannot apply t-test. So we have the alternative non-parametric test. So in that situation, we can go for the non-parametric test. I hope it is clear now. Okay. So this is how we can use, right? It will show you the box plot also for the same variable, right? And exactly same way, we can go for just, I am taking just 5 minutes. Okay. So go to analyze, then descriptive, explore. Now, instead of this, suppose I want to compare gender wise. Okay. So I can use gender as a factor and all other options are same. So we get all these things. Look at this. right? Separate QQ plot for male weight and male, separate QQ plot for female respondent, right? Histogram, summary statistics, and the normality, separate normality for male and female. Okay, so this is how we can use all these things. Okay, I hope it is clear. Okay, if you have any question, so I have taken 5 to 10 minutes, 7 minutes more. If you have any question, please feel free. I hope. Yeah, thank you, thank you. Thank you, Niranjan. Thank you, Pankajam, Kriti. Thank you. So, this is there. If no normality there, what? Okay, Kanchana. So, in one of the session, there is one session on non-parametric, right? So, if the data is not normal, so we have the alternative non-parametric test, right? So, the next session is about parametric test. So, Parag sir will give you idea about the parametric test. If data is not normal, then I think tomorrow there will be a non-parametric test session, right? So we will discuss about that. So if no normality, we have the non-parametric. So thank you very much, Lata, Kanchana, Lakshmi.
Thank you, sir.
Thank you.
Thank
Thank you,
you, sir.
madam.
I want to extend my gratitude for enlightening session on exploratory data analysis through graphs. The session was not only educational but also exceptionally engaging and insightful. Sir, your ability to convey complex concepts through visual representations are truly remarkable. The way you demonstrated the power of graphs in uncovering pattern trends and outliers in data was eye-opening. Your explanations of different types of graphs, their application, and the best practices for creating them is highly valuable, sir. Thank you so much for your session today. Let us meet tomorrow again, sir. Thank you, sir. Good night, sir.
Thank you and good night all.
Okay, participants, you can have a break for 5 minutes. Paraksha sir will be joining in 5 minutes. Please have a break.
Okay.
Be online and take break for 5 minutes. Thank you.
Thank you, madam. Thank you.
Thank you, sir. Good evening, sir.
Yeah, good evening, ma'am. Sorry, I had a little bit of work, so I'm a little bit late by 10 minutes or so.
No problem, sir. They'll be coming to the session in 3 minutes. They are gone for break, I think.
Actually, I gone for a break. Okay.
3 minutes.
3 minutes, no?
Already they have went. Just let us wait for 3 minutes.
Fine. And about the data file, I'll share it over here or I'll send it to you.
You can share here also, sir. You can share in the chat box also.
In a chat box, I can share. Okay.
Yes, sir. You can share to me also. Now you can share to the chat box.
So, sorry, what you said?
You can share to me also afterwards, sir, after the session. Now you please share in the chat box, sir.
Hmm.
I will share to their mail tonight or tomorrow morning.
I hope you have received the files.
Yes, sir.
Yeah.
I will receive the file. And tomorrow morning I'll be sending them that SPSS file. That is pending still with me.
Okay.
I'll be sending tomorrow morning.
Not a problem. So those who are back can download these files, and if you want, we can have it simultaneously hands-on. You can download this file and keep it in your make a folder on a desktop or so on.
Those who are back can come on the video so that we can see how many of you have come back. Those who have come back, please come on the video to check how many of you are here.
Yeah, that's true.
Hello, Veena
Okay,
madam.
that's great. Okay, Veena, Nitin.
Hi. She is my colleague.
Acha,
And
okay.
Dr. S. Veena.
Nitin is there. Santapa has raised his hand. Niranjan, okay. Surya, okay.
Veena, you can speak anything you like to speak.
Okay, Purnima,
Want
Rajeshwari.
to speak anything?
Yeah, you are muted, so Veena, we are not
Mute,
able to hear.
Oh, okay.
Yeah, now it's
Good
fine.
evening, sir.
Yeah, good evening.
Sir, it was really a wonderful session, sir. I'm waiting for your session. I thought that the first session would be yours. And it was really a composed session, sir. We are able to understand everything clearly, sir.
Wow, thank you. That's good.
And thank you very much for Salila madam for bringing you to this session, sir. Thank you, Salila.
Yeah, the credit goes to her for making this accessible to many across India so that they can take advantage of it.
Yes,
Thank
sir.
you,
Yes.
Veena. Thank you. Yes, sir, we can start, sir.
Okay. So good evening to all.
Sir, So, sir, yesterday we had very insightful and informative session on the fundamentals of statistics and its application, as well as the discussions on graphs, qualitative and quantitative analysis. It was also an interactive and dynamic learning environment. Today we have session on parametric hypothesis testing by Dr. Paraksha from Gujarat. Welcome you, sir. Please take the session. Thank you.
Thank you, ma'am. So up till now, you know about the fundamentals of statistics. What is data, level of measurement, which central tendency, which dispersion, which graph to use when, then how to use SPSS for all this exploratory data analysis. That much now we all are at par. That much you all know. Now we are going a step ahead in which it will be the inferential statistics. So for those who have joined late, probably after the break, I have sent the data files you can download and keep it on your desktop. Till then, I'll open the presentation so that the first 15-20 minutes or maybe 40 minutes or so, I'll be giving you the concepts about hypothesis testing. So even if you don't have the fundamentals or concept of hypothesis, don't worry, I'll be taking in such a way that it becomes clear to you. For those who are knowing about the hypothesis testing, this will help you to gain more clarity. Okay. So before we start with the concept of hypothesis, let us go into, yeah, Megha, good evening. Lata. What is population and what is sample? This everyone knows. Population means the total number of units under the field of study. Suppose I want to find out how many vote or how many have favorite cricketer as Virat Kohli. So your favorite cricketer, how many of you in India? I'm talking about in whole India. What is the percentage of individuals, those who have their favorite cricketer as Kohli? Now in this scenario, all the individuals staying in India becomes my population. The population means the total number of units under the study. So my study was for India. So all individuals in India becomes my population. Now we know it is not feasible to go to each and every individual and ask about whether you like Kohli or who is your favorite cricketer and so on. So what I do, I take a sample. I select few units from the population. But that few units should be what? Representative part of the population. So representative part of the population is called a sample. So what is the population? Total number of units under the study. Now, when I say total number of units, it can be living thing or it can be non-living thing. Okay, that is called population. And the representative part of the population is called a sample. Now, whatever calculations you do on the population observations, they are called parameters. All calculations that you do on the population are called parameters, and all the calculations that you do on the sample are called statistics. Make sense? Whatever you do, whether you calculate mean, standard deviation, range, total, whatever it is, any calculations that you do on population observations are called parameters, and any calculation that you do on the sample observations are called statistics. Now let us go in little bit detail. When I talk about mean, okay, mean, what is the notation that comes in the mind immediately? Immediately the notation that comes in the mind is x bar. Then what is mu? Mu is also mean. Difference is this mu is for the population, so it is called parameter. This x bar is for the sample, so that is statistic. But sample statistics is so frequently used that whenever mean comes, whenever we read mean, immediately what comes in our mind is x bar. So the point is mu is the parameter, but that is also mean. So for mean, population mean is mu, sample mean is x bar. Same way, standard deviation. Population standard deviation sigma, sample standard deviation is S, proportion it is capital P and small p, correlation coefficient it is rho and R. This is rho, RH2. So what is happening now? I'll talk about in real terms. We actually want to study the whole population. We want to study the whole population. But practically it is not feasible. That means we want to actually find out the value of parameter, but practically it is not feasible. So what we do, we take a sample. We study the sample. That means what we calculate statistics. Once we get the answer, we conclude that will be the answer of the whole population also. So we are actually calculating the sample and then we infer what we are doing, then we conclude, then we infer that that will be the same answer for the population. This logic is called inferential statistics. So now if you understand, there are two types of analysis. Descriptive, which you have already done. Today Raju sir has taken care of. Exploratory data analysis, which is only describing the current data, which is only describing the data that you have on hand. It may be a sample data, it may be a population data. Okay, that is descriptive. So descriptive means which describes the population, which describes the sample observation. Okay, what does it uses? It uses graphs, it uses tables, using maybe summary statistics, using the dispersions and so on. That is all about descriptive. But that is one of the phase of descriptive. The second phase is inferential analysis. And what is inferential analysis? To infer about the population based on the sample data. To infer, to conclude about the population based on the sample data is called inferential statistics. And so now we are starting with inferential statistics. So if I take you to what we have done till now, what we have done is we started with what is data. Then we talked about qualitative data and quantitative data. Then we did descriptive analysis. That is central tendency, dispersion, graphs, frequency, that is table, and so on. So that part of the data analysis has been taken care now, which is called descriptive. Now we are going with the second part, that we want to study the whole population, but we take a sample, we study the sample, and whatever results we get from the sample, we'll infer it for the population. That is called inferential statistics. So now we are going with hypothesis testing. In that it will be t-test. We'll be going with chi-square test. We'll going with ANOVA. We'll be going with non-parametric test, and so on. So this all comes under inferential statistics. All hypothesis testing comes under inferential statistics. So this is okay, that is fine. Now we'll start with hypothesis testing. So first we need to understand what is null hypothesis. So null hypothesis is a general statement about population parameter or about relation between two or more population parameters. So in general, what is null? Null means a statement about population. Any statement. Statement about the population parameter or relation between two parameters or three parameters is called null hypothesis. It is denoted by H0. H for hypothesis, and as it is null, so we are writing down 0. H0. So what is null? Null hypothesis is any statement about the population parameter or relationship between the parameters. Now there can be two types of null hypothesis, simple and null. That is simple and composite. Simple means it takes exactly equal to sign. Equal to. And composite means it can take greater than or equal to or less than or equal to. If you observe one thing, null hypothesis should have an equal to sign. Either it may be a pure equal to sign, or it may be greater than or equal to, or it can be less than or equal, but it should have an equal to sign. In majority of Indian author books, you will find only simple null hypothesis. But in real life, in foreign author books, you can come across composite null hypothesis depending on the problem. I'll discuss both at length, simple and null. Okay, simple and composite based on the data that is. But what is to be remembered over here? Null hypothesis should have an equal to sign, either pure, greater than or equal to, less than. I hope everyone is with me. Yeah. Okay. Next is alternative hypothesis. Alternative means complementary to null. Whatever options we have taken in null, all other options comes in alternative. This means if I take an equal to as null, what are the other options left out for equal to? If it is equal to, then it will be not equal to. If I say greater than or equal to, say this way, this is greater than or equal to. Then what is left out? This side is left out. What is that? Less than. If I take less than or equal to, what is left out? Greater. If I take equal to, what is left out? Both sides are left out. So that is why it is not equal. Okay. So that means if your null hypothesis is equal to, your complementary to equal to will be not equal to, which is called two-tailed. Now, why it is called two-tailed? Let me explain. This is a normal distribution. This is equal to, say this is mu equal to 50. So what are the other options left out? This is null. So it can be either less than or it can be greater than. So it can go on both sides. Now, as it can go on both sides, it is called two-tailed because it can go on both sides. Here, if you observe, I am having greater than. So my null is, this side is my null, mu greater than or equal to 50. So now we can go only on the other side of it. I can go only over here. So that is called one tail. But which sided it is? Left. So left sided one tail hypothesis. Same way it will be right sided one tail hypothesis. So that is how null and alternative is decided. Okay. Now I'll take some practical case studies because in this hypothesis testing, the most difficult part is null and alternative. Null hypothesis and alternative. Once you are clear with this hypothesis, remaining all will be done by SPSS. Remaining everything will be done by the software. So that is not a big deal. That the machine will do. But deciding null and alternative require human intelligence. And that is where we have to play the role. Okay. So now I'm taking the case studies. Read the question. In a Bell customer service department, the average response time to the customer's inquiry was 120 minutes. Now, whenever you give a call at the customer care, your problem was resolved on an average in 120 minutes. Company thought that this is too much time for the customer to wait for 120 minutes to get the problem resolved. So they introduced a new system to improve the response time. Okay, so the company invested a lot in the new system. After investment, now they want to check, they want to test if the average response time has decreased. Whenever a company invests something, after that they will check whether it has improved or not. So that is where we have to help them to decide null and alternate. So now what we will do is, I'll explain everything in detail. So here, the parameter, first of all. Which parameter is of our focus? Or okay, before that, I will talk about decision variable or the focus variable. Which is the focus variable? Response time. Response time is my focus variable or decision variable. Response time. Which is the parameter we want to understand? Whether it is average or proportion or standard deviation. What is our focus? Our parameter is average. Our parameter is average. That means mean. Now, what was the question? What was the question? They want to test if the average response time has decreased. So they are asking us a question. We are a statistician. Okay, we are their consultant, and we want to solve, has the average response time decreased? What can be the answer to this? Yes or no? Either increased or it has not increased. You assume any one answer, your choice. Suppose we say that yes, it has decreased. What has decreased? Average response time has decreased. Then what was the first average response time? Average response time was 120. And now we are saying it has decreased. Decrease means what? Mu less than 120. Then only we can say it is decreased. That is mu less than 120. What will be complementary to this? For less than, what are the other options left out? If you recollect, I had explained this. This is less than. What are the other options left? The other options left will be mu greater than or equal to 120. Now, out of this two, if you recollect the definition, equal to comes always in null hypothesis. So where is your equal to sign? This is the equal to sign. So this becomes my null hypothesis, and this becomes my alternative hypothesis. This is how, based on your problem that you are dealing with, industry problem or your research problem, you have to decide your decision variable, your parameter, your null hypothesis, and alternative. Any questions? I have taken 5-6 such case studies because I want you to clear with null and alternative. Then only we'll go further. Any questions? No? Veena? Lata? Shyam? Satish, that is also a false notion that null will always be in a negative form. No. We don't have to worry about the whether it is negative form or whether it is always taken in negative sense or positive sense. We will not go in that flow. We'll always go in the form of the question that is asked. Yes, Swapna. So your question is why greater than 120 in null? You have not taken greater than, it is less than. Because we say, yes, it decreased. So, okay, let me explain it in another way. Yeah, I said over here that yes, it has decreased, right? What I said here, let us take yes, it has decreased. Decrease means so it is less than. Complementary to less than was greater than or equal to. and here it is equal to, so I got null over here. Now I change my logic. Suppose the question was asked, they want to test if the average response time has decreased. Our answer could be yes or no. I have taken yes over here. Suppose now I take no, that means it has not decreased. Okay, what does that mean? If I take that the average response time has not decreased, not decreased means what? Mu. Not decreased means what? It has not decreased, means it is either equal to or greater than 120. It has not decreased, means it is either same or it has increased. So here we are saying no, it has not decreased. What will be complementary to this? Greater than or equal to, complementary will be less than 1. This means it has decreased. Where we have an equal to sign, we have an equal to sign over here. So this becomes our null and this becomes our answer. So whether you take yes or no, the answer null will always be greater than or equal to in this case. Here you can see null is greater than or equal to 1. So don't worry about whether you are taking yes or no. Carol, correlation comes into the picture when we deal with two variables. Here it is only one variable. So it is nothing about relationship right now over here. But whenever we are interested in finding out whether there is some association between two variables, whether there is some relationship between two variables, then correlation comes into the picture. Carol, make sense? Okay, sir. Your point will be clear. So let us take the next example. Indus Wellness Company. Read the question. Indus Wellness Company launches a new weight loss program and claims that it helps the people to lose on an average at least 3 kgs within 1 month. Government's National Consumer Protection Center wants to test if the new weight loss program indeed leads to a weight loss of at least 3 kgs. Question is clear? So we'll start with the data. Which is our decision variable? So one by one, write down in the chat box. Which is our decision variable? Weight loss. Perfect. Okay, Satish, Prashant. So here it means weight loss. Decision variable is weight loss. Which is the parameter we are focusing? Which is the parameter? Parameter average. Yes, Tessie. Perfect. So that means the parameter that we want to focus over here is average. Why? Because it is given on an average at least 3 kg. So my parameter is average. That is. What was the claim of the Indus Wellness Company? What was the claim? Claim was at least 3 kgs. It will reduce the weight by at least 3 kgs. At least means what? So we are saying the claim is true. Suppose we start this way. That whatever Indus Wellness Company is claiming, it is true. True means what? At least means greater than or equal to 3. What will be complementary to this? This is greater than or equal to. What is complementary? Less than 3. Out of this two, where we have an equal to sign is over here. That becomes our null hypothesis. This becomes our alternative hypothesis. Better understanding? Okay, we are taking 4-5 different sums, so don't worry. Yes, Prashant, Teshi, Swapna, Satish. Great. You are all with me. That's great. Any doubt for this? whenever you have come across your problem, whichever problem you are addressing, whichever problem you are trying to solve, this is how it has to be started with. What is your decision variable? Which is our parameter of focus? Then what is the question asked? We say the question asked, is it indeed at least 3 kgs reduced or not? So you can start with yes, it has reduced or it has not reduced. You can start with any one answer. Suppose we say yes, it has reduced. Reduce means greater than or equal to. Complementary to this will be less than. Here it is equal to sign, so that becomes null and the other becomes false. Sure, next. I want this questions. Decision variable, parameter, then we'll decide null and alternate. Which is the decision variable? Swapna, Lata, Satish. Yes, Satish. Equal to sign for null and alternate. Fish that survive. Perfect. Swapna, that is right. So that means the proportion of fish that survive. So we'll say survival rate, or we can say whatever you wanted. Which is the parameter? Is the parameter average over here? Okay, Tessie, Vinci, perfect. Proportion, that's great. So we are talking about the proportion. Percentage or proportions are same. So our parameter is proportion. Wonderful. So first thing is decision variable, second is parameter. What is the question asked? A fisheries biologist want to assess if the proportion of fish that survive in a particular lake river is below critical threshold level of 0.8. So the question is it below 0.8? You can answer is a yes or no. Okay, suppose I'm answering yeah, it is below. We say yes, it is below 0.8. So proportion below 0.8 means less than 0.8. Right? Because whatever is given to you, below. So we say yeah, below means less than 0.8. What will be complementary to this? So complementary to less than will be what? Complementary to less than will be greater than or equal to. Because less than we already have over here. What is left other than less than? Greater than or equal to. Here we have an equal to sign. So this becomes null hypothesis. This becomes alternative hypothesis. Okay. Vijaya Lakshmi, Lata, Satish, Tessie. You all are with me now. I think now you are getting into the groove of how to decide null and alternate. Next. Make it fast. Decision variable. Parameter. And then we'll decide null and alternate. So what is the decision variable? Signups. Perfect. Consent. Satish. Signups will be considered as the decision variable. Which is the parameter we are focusing on? Yes, Satish, Nitin, Kanchan, proportion, Carol, perfect. So we are dealing with, okay, Kriti. So we are dealing with proportion. That's great. Okay, Lata. So that is perfect. What is the question now? Flipkart has a website sign up of 15%. Well, of those who visit Flipkart, out of that 15% go for sign up. Okay, that was the question. Now they started with a digital marketing company. They launched a new this to increase the website sign up. Now company had given a contract to this new digital company, digital marketing company. Wow, Prashant, Tesi, that's great. Satish. So they wanted to check. Now what they want, what is the problem? They want to determine if the proportion of sign-ups with the new campaign is significantly higher than the historical proportion. They want to check, has it increased? We have paid a lot of money to digital marketing company. Has it increased? Now, when can we say that it has increased? We can say it has increased if it is greater than the historical part. What is that? 0.6. What will be complementary to this? This is equal to greater than. What will be complementary to this? This will be less than or equal to 0.15. Here it is less than. So this becomes null. And this becomes alternative. This is how null and alternative is defined. Perfect. Sure. Next. I have taken inner sums for clarity, so don't worry. Decision variables, parameter, what will be the decision variable? Kanchan, Veena. Kanchan, percentage is a parameter. Okay, percentage we can say it is a parameter. Percentage means proportion. What will be the decision variable? Potential commuter. Perfect question. Commuters will be the, so see the question. The policy of the suburban transit authority is to add a bus route if at least 55% of potential commuters indicate that they would use a particular route. So decision variable is potential commuters. The decision variable potential commuters, parameter is proposed. What is the question? Does the Bowman to downtown route meet the STA criteria? STA means Sub Transit Authority criteria. So when it will meet the criteria? It will meet the criteria if P is at least means greater than or equal to 0.5. Then we say it meets criteria. What will be complementary to this? This is greater than. What will be complementary to this? Less. Where you have an equal to sign, we have an equal to sign over here. So this becomes null. This becomes alternate. Easy? Yes, Vinci, Satish, perfect. Any doubt? Sure. Next. Crop yield, Swapna, perfect. Crop yield. Yeah, Lakshmi. Vijay Lakshmi. So you can say average crop. So crop yield. Crop yield becomes our decision variable. Parameter is average. That is also true. Now, how many types of cone we have here? 2. Yes, Vinci. So it is 2. 2 different. Yes. Up till now, we were talking about only one population or one sample. Here, there is 2 different. So my populations are. So what is the question? A farmer wants to determine if there is a significant difference in the average crop yield between the two different varieties of corn. So what is this case? I'll explain. Suppose this is a farm. Okay, in farm 1, he uses the first type of corn wild, first type of corn, and he calculates how much yield he is getting it. In the second farm, he goes with corn 2. Now he wants to compare, is there any significant difference between the two? So what will be the answer for this? What is the question asked? Is there any significant difference in the average? So the answer may be yes, there is significant difference, or there is no significant. You can answer in this way only. There is difference or there is no difference. Suppose we start with there is no difference. When I say there is no difference in the average yield, no difference means what? They are equal. Mu1 equal to mu2. Means there is no difference. Makes sense? What will be complementary? Whenever there is equal to, what will be complementary to equal to? Not equal. Well, there is difference. You have an equal to sign over here. So this becomes null. This becomes alternate. Equal is null. Perfect. Vinci, Satish. Vijayalakshmi, Vinci. Perfect. I want others also to answer, because I want everyone to be clear with the concept. For your own research, for the company that will go further in your future, right now also if you're working somewhere, this is something which will be very, very important. Chalo, next. We'll keep this as a last. Then we'll go further. This is just for null and alternative. Decision variable, parameter, how many populations we are talking about. Then we'll talk about null and alternative. Sales, perfect. So Prashant, you are right, it is the sale. So the board of director wants to determine if the average, the parameter is average. Average sales, so my decision variable is sales, increases by advertisement through social media than on television. So there are two populations. One, sales through TV, and sales through social media. There are two populations, right? What is the question asked? Is the average sales increases by advertisement through social media? So your answer could be yes, it has increased, or it has not increased. Suppose we start that it has increased. What has increased? Sales, average sales. Sales of what? Sales because of social media has increased, means it is greater than the sales of TV. Sales by advertisement on TV. So sales by marketing on social media is increasing the sales than that of TV. What will be complementary to this? Greater than means less than or equal to. Means it has not increased. So this is equal to sign. Here it is equal to sign. So this becomes null. This becomes alternative. So this is how one sample taste, two sample taste will be decided. This is how which taste to use, that also will be decided. Okay, Lata, Satish, Prashant. Okay. Sure. Nitin, clear? Okay. This is okay. This is not a point right now. Now we'll talk about the p-value. In certain cases, such as you are right, in negative form it holds true. But if you go into that concept, you may be wrong many a times. So instead of that, don't go whether null will be negative or null will be positive. We'll not go into that. We'll only answer the question yes or no. Whatever the problem is, we'll either answer it as yes or we'll answer it as no. And automatically that will give you null and alternate. That is the easiest way. Okay. Now, if you have done hypothesis testing before, if you recollect, we were actually calculating the values of say the formula for Z was there, modulus of x bar minus mu divided by sigma upon root n, or it was x bar minus mu divided by s upon root of n minus 1, and so on. We were using formula, and then we were calculating the table value. So from T table, from Z table, from chi-square table, we were finding out the table values also. And then every time this value was compared with the table value, or Z value was compared with the Z table value, and so on. So it was a very difficult task for the non-statistician. Priyadarshini, why everyone is talking about null as negative? Not necessary. Here, see, it is positive. Here you can see it was positive. Greater than or equal to. Here you can see it is positive. So Priyadarshini, it is not always that great. Everyone talks it in a negative. See, I would say there are many false notion about hypothesis testing, about null and alternative. Many of the books is misleading. If you read that book carefully, then it misleads us of interpreting null and alternate. But make things simple. Don't interpret anything from that in predefined way that null means it will be having a negative sense and alternative will be having a positive sense. It's not that. If you make it open, then it will be easy for you to write down null and alternative correct. I hope I have answered your question, Priyadarshini. Yeah. Okay. So now up till now we were comparing T table with the T value, Z table with the Z value, and so on. It was becoming very difficult for all the non-statisticians that every time we need a new table. So now when software came, maybe it is the Excel, maybe it is SPSS, maybe it is Jamovi, maybe it is R or Python, we don't require Z table or T table. We will calculate the p-value only. We will calculate p-value. And that will be given by the software itself. The p-value will be given by the software. So directly now our focus will be, instead of going with all this, our focus will be the p-value. If p is less than or equal to 0.05, why 0.05? That depends on the alpha. Alpha is a predefined value, level of significance. Alpha is a predetermined value. Generally, the alpha prevalent values are 1%, 5%, or 10%. These are the alpha values. But what happens that 1, 5, and 10, okay, let me explain you the level of significance also. Yeah, level of significance. So what does this mean? 1%, suppose I take alpha 5%. It means 100 times if I do this experiment, 100 times if I do this hypothesis testing, 5 times I may reject true null hypothesis. So our hypothesis was true, but still there are chances that we reject it. And that may occur 5 times out of 100 if you take alpha as 5%. So that means if you take alpha as 1%, it means out of 100, one time you may reject a true null hypothesis. If you take alpha is equal to 10%, out of 100, 10 times you may reject the true null hypothesis. In other words, alpha is your risk. This is high risk, this is low risk. And alpha is equal to 5% if I take, it is a medium risk. So that is why generally in the market, 5% is prevalent, because this is very low risk. And if you want a low risk, then your sample size should increase. And so your cost will also increase. If you're taking high risk, then the cost may decrease, but the risk is very high. So to balance out, we take alpha as 5%. Yeah, Prashant, that alpha is not an example, I would say. Okay, let me explain with the case of domain. When we are going with a pharma company, pharmaceutical company, okay, pharmaceutical company. In pharmaceutical company, the risk has to be minimum, even less than 1%, because we are dealing into humans in pharma. We are giving some drugs, we are giving some medicine. So here they are investing crores and crores of rupees in research. They are investing crores and crores of rupees in research. And so here the risk has to be minimum, that after it is gone into the market. So drug was good, but it was into the market and then it got rejected. It went into the market, but due to some reason, due to some quality issue, due to some issue, it got rejected in the market. That is the risk of the pharma company. And as the pharma company is investing huge in research, they have to take minimum risk of rejecting a good drug into the market. So for pharma, alpha has to be minimum. But if it is, say, some production, say steel production, iron production, here you can afford to have alpha greater because you're not dealing into humans. And there is not a lot of investment in research and kind of thing. So even if it is a good quality iron, it goes into the market and gets rejected. Then it is not that much huge loss as the pharma company would incur if it is rejected, the drug is rejected in the market. So here you can keep alpha as 10%. Here alpha should be 1%. So depending on the domain you are working for, depending on the investment that you have made, you have to decide alpha. Okay? Yeah, Vince, you are right. Researcher will, not researcher actually, it is a sponsorer. Sponsorer decide the alpha. For academic research, we have to decide. That is fine. But if you are doing research for some company, then the sponsorer has to decide what is the value of risk, what is the risk that he is ready to take. Make sense? Okay, Sridevi, you want type 1 error? Then I'll have to take this. I was planning to skip this because I thought that you all are knowing this, but let me explain it. Type 1 and type 2. This means your hypothesis is true. Okay, and if it is accept, not rejected means accepted. If it is true, it is accepted, it is a correct decision, no error. It was true and it got accepted in the market. So it is correct decision. If it is false and it gets rejected, Again, no error. It was false and it got rejected. It was true, it got accepted. The problem lies when it is a cross correction. When a true hypothesis is rejected, that is called type 1 error, and its probability is called alpha, which is called level of significance. And vice versa. If hypothesis is false and it gets accepted, then it is called type 2 error. It was false. So actually it should be rejected. But not rejected means as a layman, you can say it is accepted. So it was false, but still it got accepted in the mark. So that is called type 2 error. So these are the errors that come across in hypothesis case, alpha and beta. Now it's clear? Sridevi? Fine. Sure. Now we'll decide which test to use when. See, we will not use Z test now. Z test is used only and only if population standard deviation is known. That means if sigma is known, which is never known, then only you have to go for Z test. Practically, this is never known, so this is never used. So for averages, we will never go for Z. We'll always go for T test. For proportion, it can be Z. But for Z test, that is for average, we'll not use it. So understand how to use which test. Again, it goes back to the level of measurement. So this will help you to recollect also. Let me check. Suppose your data is scale and normal. Yesterday's lecture. The data is, what is the data? It is scale and normal. Scale means it can be height, it can be weight and so on. And is also normal. Which parameter we'll have to use? Recollect the last lecture. Which parameter we will have to use? Answer in the chat box. Then only I can go for mean. See, I cannot go for median. Yeah, Prashant, perfect. Swapna, you are right that it's a t-test, that is okay. But point is, if your parameter is, that is, if your data is scale and it follows a normal distribution, then I have to go for mean. Okay. And now if it is only one sample, then you have to go for one sample t-test. You have to go for one sample t-test. If it is two samples, then there are two options. Either the samples are independent or the samples are dependent. So that we'll take it for dependent sample. And if it is more than two samples and we want to compare the means, then we'll have to go for ANOVA. So what is ANOVA? ANOVA is to check difference between the means of more than two samples. Up to two, we have t-test. One, it is T. Two, it is T. But more than two, we'll have to go with ANOVA. And if it is a dependent sample, then it is called t-test for dependent samples and ANOVA with repeated measure. This is how the hypothesis testing is decided based on the level of measurement, based on the parameter and the number of samples you have. Suppose your parameter is not mean. I don't want to check average. Say, for example, I want to check, okay, I'll take it this way. I want to compare Chennai and Ahmedabad. I want to check the average income of Chennai and Ahmedabad. Then I know that average income of Chennai is higher than that of Ahmedabad. So that means I don't want to compare the mean. I don't want to compare the average. I just want to check, is the variability of income in Chennai more compared to the variability of income in Ahmedabad? let me take an example of Mumbai. We know in Mumbai, the average income is very high. Average income is high. But we have, what we have a slums over there, and we have a Naribal Point also over there. Area like Nepean Road and all. So the variability of income is more. So I want to compare the variability of income. Okay, dispersion of income. Then I'll have to go for standard deviation. So my purpose is not, or my parameter is not average. My parameter over here is standard deviation or variance. In that case, for one sample, I'll go with the chi-square test. For two samples, I'll go with the F-test. And for more than two samples, I'll go with the Bartlett test or Levin test. So this will make you clear when to use t-test, when to use F-test, when to use chi-square test. Vinci, suppose you have one independent variable and two dependent variable, which test to use? It can never be one independent and two dependent variable. It will be vice versa. Two dependent and one independent, it may be one dependent variable. Then we'll have to go for regression. Then we'll have to go for regression in that. Okay. Now the next part comes, if my data is scaled but not normal. Possible? Suppose I'm having my data as income. So income is scaled, but it is not following a normal distribution. It is not following normal. This is not normal. Then I cannot go for mean. Remember, I cannot go for mean. What I have to go for? Which parameter I have to go for? I have to go for median. And in that scenario, I'll have to go for all non-parametric tests. So whenever your data may be scaled, but if it is not normal, then you have to go for all non-parametric tests. And these all are called parametric tests. Now I'll explain about what is non-parametric test, which to use. If it is one sample, then Wilcoxon sign test. If it is two samples, then Mann-Whitney U test. More than two, then we'll have to go for Kruskal-Wallis test. If it is dependent samples, then Wilcoxon test for dependent and Fredman test. In other words, you can say one sample t-test is same as Wilcoxon test. But the only difference is this is for mean, this is for median. Same way, t-test for independent sample is for mean, Mann-Whitney U test is for median. Now the third case occurs, suppose your data is not scaled, it is nominal. Nominal or ordinal, your data is nominal or ordinal. Then you have to go for proportion. And in that case, you have to go for Z-test for one sample, two sample, and chi-square test for more than two proportions. If it is small sample, then sign test, chi-square test, and chi-square test for two. This slide will help you to decide when to use which type of. This becomes ready reckoner for you. So now what to do whenever a problem comes to you, check out what is the decision variable, then check out whether it is scale or so, then check whether it is normal or not, then check out what is the parameter, how many samples we have, and automatically you will come up to the test. Correct hypothesis test will be decided. Okay? So, any questions for this? So now we will start with hands-on SPSS one by one. I will be taking 1, 2, or 3 tests. As the time permits, I'll be taking different tests for you. I have sent the data in the chat box. You can download it and keep it in a folder on a desktop. You can open, if you want to do it simultaneously with me, you can open the SPSS file and do the test for me with me. Or else you just understand what it is done and then you can practice it later on, because data file is sent across and this video file is directly uploaded in YouTube. You can refer to that and also understand. Now the steps. First step and second step is always null and alternate. First, second step is null alternate, and now we know how to decide it. Third step, which normally everyone skips, academically everyone skips this test, that is checking the assumption. But this is very, very important. Fourth step, software will do it for you. Fifth step, the answer that you get from the software, you have to simply conclude. What will be the conclusion? P less than or equal to alpha, we reject null hypothesis. This is rejected. And greater than alpha, we fail to reject. Fail to reject means in layman language, we accept the null hypothesis. So these are the 5 steps you have to follow. Whatever hypothesis testing you are doing it, same 5 steps. 1 and 2, null alternative. Step 3, assumption. Step 4, the p-value. Step 5, the conclusion. Step. Now we'll start. T-test for single mean. Null and alternative. So that is either it will be equal to, then it is not equal to over here, less than or equal to, then it is greater than or equal to, it will be less. So that is about null and alternative, which I'll already explain and I'll take in the further case studies also. Next part is checking the assumption. And this will help you to go back to the table. When we have to use a t-test, we have to use t-test. First, it should be scale. My decision variable should be scale and it should be normal. Make sense? It should be scale and it should be normal. Then only I can use it. So that is the assumption we need to check, whether my variable is normally distributed or not. Whether my variable is normally distributed or not. And which are the tests to be used? Shapiro-Wilk test or QQ plot will be used. These are authentic tests. There are other tests also. We can go with histogram. We can go with frequency polygon. We can go with box plot also. But they become subject to interpretation. If we want an authentic result, then the tests are Shapiro-Wilk test and QQ plot. Okay. There is one more assumption we need to check, that population variance is unknown. Why we need to check this? Because if sigma square is known, the second assumption was sigma square is unknown. Because if this is known, then I have to go for Z test. So we will check this also, whether the population variance is known or not. If it is not known, if my data is scale and normal, then only I can go for t-test. Unfortunately, whenever the research paper comes to us as a referee or as a editorial board, no one is checking this. They always go for t-test. Even some of the PhD guides also guide their students that I want t-test in your thesis. I want t-test in your paper. They never check, is it applicable or not? So that is the reason assumption becomes one of the very, very important parts, that you can use t-test only and only if the data is normally distributed and variance is unknown. Then step 4 and 5 is okay. Aminu, I'm sure that madam is taking the videos of this, so it is live on YouTube, so it will be shared to you. So that won't be an issue.
After 4 days, after this program is over, we will share. After this program is over, we will be sharing.
Okay. So
After
ma'am is
30th of
kind
November.
enough to share it. So
Yes,
she'll
sir.
be sharing once the program is done. So you can refer it. Chalo, we are starting with a small data. I want everyone to understand it. Based on the field experiment, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. The variety has been tested on 10 randomly selected farmers' field. The yield were recorded in the file. So I have given you a file name called greengram. Greengram.xlx. So in Excel file, the data is sent to you. You can right now also open SPSS and do it, or else I'll explain it one by one. Yes, Bunny, example one, perfect. Okay, so now first thing is to decide the points that we have already discussed. So in the solution, first step, what is the decision variable? What is the parameter? How many samples we have taken, samples or population we have taken? And then we'll decide what? Null and alternate. What is the decision variable? Great. Yield. Perfect. Parameter, average. Sample is taken only once. I don't want to compare the two type of green gram. It is taken only one. So, what is the question asked? Based on the field experiment, a new variety of green gram is expected to give an average yield of 12 quintals per hectare. Do the result confirm the expectation? What was the expectation? That it will give 12 quintals. Right? The expectation was it will give 12 quintals. So what will be the answer for this? Yes, it gives 12 quintals, or we can say it does not give 12 quintals. It is your choice. Suppose I say it gives 12 quintals. On an average, it gives 12 quintals per hectare. So mu is equal to 12. What will be complemented to this? Complemented to this will be mu not equal to 12. So this becomes our null hypothesis. This becomes our alternate. I hope everyone has done it perfectly. Right? So now null and alternative is decided. So not equal to means it is a two-tailed alternative hypothesis. You know why two-tailed? Not equal to means it can be greater than also, it can be less than also. So we can go on both sides. So it is a two-tailed alternative hypothesis. So now I'll start. So open your SPSS if you're doing it simultaneously. Because see, what we are doing it, step 1, step 2 is done. Step 3, so let me explain again. Step 1, step 2 is done. This is my step 1 and 2. What was step 3? Assumption. Which were the two assumptions? First was normality, and the second was population variance, whether it is known or unknown. If you read the whole sum, whole data, is population variance given to you? Anywhere? Is population variance given? No. Here, it is not given. Okay, Prashant, it is not given. So that means population variance is unknown. So this assumption is done. Now what is left out? Normality assumption. So now we will go with step 3, that is normality assumption. And for that, what to do? You have to open your data. So this is how the data will look like. Then go in analyze. In that descriptive statistic, in that explore. In analyze, you have to go in descriptive. In that, go to explore. When you open this, a new box will open, and it will show a decision variable over here. Put that variable in our dependent variable. Okay, that we have done it over here, and then here it will be statistics. Click on plots and statistics, or we could click on plot. If you click on plot, this will open. In that, tick mark over here, normality plot with test. Because I want Shapiro-Wilk test. I want QQ plot. So we will tick mark over here, normality plot with test. Then up to this, Aminu, it is sent. This file, greengram. Let me check. Greengram, it is given 8.24 KB. This is first, second, third, fourth file is greengram. Got it? So next, once you click on this, this is what will be coming as an output. You will get this as an output. There will be, see, where we have clicked normality test. So there is a Kolmogorov-Smirnov test also, and there is a Shapiro-Wilk test also. But we'll focus on this one. This is also a good test, but we'll focus on Shapiro-Wilk. So what to do now? Understand it carefully. If you're doing it for the first time, you need to understand its interpretation. Check out the p-value. See what it is giving you. Statistic means this is the value of W, Shapiro-Wilk. This is degrees of freedom. And this is significance value, means this is called the p-value. Significance is the p-value. So when you click on this, you see p is 0.891, which is greater than 0.05. Greater than 0.05 means it is normally distributed. If it was less than or equal to 0.5, less than something, then it is not normally distributed. So whenever the value of p is greater than 0.05, for normality particularly, we will say it is normally distributed. Done up to this. Yeah, ma'am is kind enough to send a greengram file again for those who are not getting it. Okay, so this is done. So my third step is done still. Understand, step 1 and 2, null and alternate. Step 3, assumption. In assumptions, there were 2, normality and population variance. Population variance was unknown. So that is done. Population variance is unknown. What was second? It should be normality distributed. We are getting it is normally distributed. If this both assumptions are valid, then only I can go with step 4 for t-test. If it is not valid, then I'll have to go for a non-parametric test. If normality is not valid, I'll have to go for a non-parametric test. If the population variance is known, I'll have to go for a Z test. To understand how important the hypo assumptions are. And normally it was ignored. Okay, step 3 is done. This is the QQ plot. If the points are very close to the diagonal line, this is the diagonal line. If points are close to this, then we say it is normal. Okay, then we say it is normal. But Shapiro-Wilk test, when it says it is normal, QQ plot, without even seeing, you can say it is normal. Now we'll go for step 4. That means to find out the test statistics and the p-value. So for that, go back to analyze. In that, go to compare means. In that, we know it is only one sample. So one sample t-test. So what we are doing now, we are going with step 4 now. Once you click on this, a new window will open. Take this yield as the test variable. This is the mu value. Can anyone say what was our null hypothesis? Anyone can remember what was our null hypothesis? Equal to 12. Yes, Vinci. So now this test value means it is 12. This is what we'll have to do. So we have taken this yield and here we have taken the test value as 12. Because null will always have an equal to sign. And so we can put whether it is greater than or equal to, less than or equal to, or equal to. We will put over here the value itself. Once this is done, click on OK. If you click on OK, this OK, you will get the output. In that, this is the test statistic, T. Test statistic. This is degrees of freedom, n-1 degrees of freedom. And this is the p-value. Now observe the p-value. Here it is automatically giving for two-tailed. It was two-tailed. What was our null hypothesis? Our null was mu equal to 12. Alternative was mu not equal to 12. Not equal to means two-tailed. So this is the value for two-tailed. This is confidence interval and so on, not required right now. So what does it interprets? Step 5 is the conclusion. Step 4 is done. That this is the t value and this is the p value. How is the conclusion to be done? Using p value. What is p? 0.1. 0.1 we have to compare with what? Alpha. Generally alpha is taken as 5%. So my p value 0.1 is greater than 0.05. Greater means what to do? We fail to reject. Just remember the step. Greater means we fail to reject. And when we say we fail to reject, means we are accepting the null hypothesis. We fail to reject means what? In a layman language, fail to reject means we accept. We accept the null hypothesis. What is our null hypothesis? That the average yield is 12 quintals per hectare. So we accept this. So the new variety of green gram is now expected to give 12 quintals of average yield per hectare. This is how the conclusion is done. Any doubt? Any doubt for it? No. That's great. Okay, Vinci. Aminu, the value of t, if you want to do that, the value of t needs to be compared with the table value. This is t. If you want to interpret from this, you need to have a t table value. And then you can compare. Otherwise, it is of no use. Conclusions will be made on p value only. T value can have an interpretation, but right now we don't need it. Kanchan. Because we are making the conclusion using P. We are making the conclusion using P. So no need to interpret from T. If you want to interpret from T, you need to have a table value for it. T table. And then the interpretation can be done using the table value. So next. One more. And I'll make it a little bit fast now. What is the data? A researcher is investigating the hemoglobin levels of schoolgirls in a particular area. 15 schoolgirls were randomly selected and their hemoglobin is as follows. So it is given in the data file HB_girls. Does the data reveal that the average hemoglobin levels among the girls is more than 11.5? So chalo, we'll start with our logic. Decision variable, parameter, samples, then we'll decide null and alternative. Perfect. Hemoglobin level parameter is average. That's great. And samples are 1. So decision variable is hemoglobin level. Parameter is average. Sample is only 1. Now what is the question asked? Does the data reveal that the average hemoglobin level is more than 11.5? Now if that is the question, you can answer it as yes or no. Your choice. I'll say yes, it is more than 11.5. So mu greater than 11.5. We'll say yeah, it is more than 11.5. What will be complementary to this? It is more than. So what is left out? Less than or equal to 11.5. This becomes our null hypothesis. This becomes our alternative. Easy? Perfect, Prashant. Now, step 1 and 2 is done. What is step 3? What is step 3? Assumption. What are the assumptions? One is normality. And second, population variance. In the whole sum, if you read the whole sum, is population variance given? No. So this means it is unknown. This assumption is checked. Now we need to check the normality assumption. Perfect. Great going. Okay, Lata, Prashant. So now we are going with that. How to check normality? Go into analyze, descriptive statistics, explore. Once you click on explore, this decision variable here has to be shifted it here, hemoglobin. Then click on this. When you go on plots, click on normality. Now you know how to do it. When you click on normality plots and test, you will get this answer. We'll go with this. will only check the significance. Significance means the p-value. So p is 0.505 greater than 0.5. And so the data is normally distributed. Whenever it is greater than, then it is normal. If you get less than, then it is not normal. So here the data is normal. Done up to this? See, I'm going a little bit slow. I know it is already 10 past 9, but I want you to do it hands-on. Yeah, if you're not doing it hands-on, understand it properly, the steps, so that you can replicate this with your own data, or first of all, replicate with the data that I have sent across, and then you replicate with your own data set. So step 3 is done, the data is normal. Step 4, what to do? Take statistics and p-value. So go into analyze. Now go into compare means. Still it is one sample. So go for one sample. What was our parameter? Hemoglobin. What was our decision variable? Hemoglobin. Take it over here. What will be the test value now? What was taken in null and alternative? Over 11.5. So that this value you will get it from your null hypothesis. Once this is done, click on OK. Click on OK. You'll get this result. Then this is your t value. And this is your p value. See now the problem. Understand it carefully. SPSS always gives you the p value for two tail. What was our null and alternative? More than 11.2. So alternate null was less than or equal to 11. So this is actually one tail. Our alternative is one tail. It is only greater than. And here it is for two tail. And so we'll have to divide it by 2. To convert a two tail p-value into one tail p-value, we'll have to divide it by 2. So p-value for one tail will be 0.214 divided by 2, that is 0.107. So don't forget this. SPSS always gives you for two tail. First sum, it was two tail, so we directly took the p-value. This is one tail. It can be less than or greater than. Don't worry about that. It can be less than, greater than. But here it is one tail. 0.107, which is greater than 0.05. Greater than means we fail to reject. Fail to reject means we accept. And so we say the average hemoglobin level of the girls is not more than 11.5. 11.5. Any questions now? This is only and only for one sample t-test. Similarly, I will take it tomorrow for two sample independent and dependent rows. This is how we'll have to go for two samples. Okay? Any doubt now? But I want you to practice this. Unless and until you won't have an hands-on, you will not be able to understand the concept. So do it hands-on. I'll be expecting you to do it tomorrow, before my session, so that you get an idea about how hypothesis testing is done using SPS. Okay. Any doubt till now? Otherwise, we'll stop.
Yes, sir. I'll be sending and I'm parallelly sending the material to the Gmail of the participants. They can check
Acha.
sending the materials. I've already sent. Let them go and check.
Arey wow, great.
Okay, sir.
Okay,
It was a great
so-
session today. I wanted to express my appreciation for the enlightening session on parametric hypothesis testing. Your expertise and the way you presented the material greatly enhanced our understanding of this complex statistical topic. Your clear and structured explanations of the key concepts from formulating hypothesis to conducting tests like t-test and ANOVA was instrumental in making the subject accessible. We particularly value the real-world examples you provided, which helped us to see the practical applications of parametric testings in various fields. Your ability to answer questions and address our concern in a comprehensive and approachable manner was highly commendable. It created an environment that encouraged active participation and made the learning experience more engaging. We are looking
Thank you.
forward to applying the knowledge and techniques learned from this session in our research and analytical work. Thank you, sir, for your dedication to making this session both informative and interactive. Thank you so much, sir.
Thank you. Thank you and good night to all. See you tomorrow with 2 sample taste and we'll go ahead with it. And thank you, ma'am, for the kind words.
Thank you, sir.
Thank you.
People are still in the session until 9:15. They are there. They are very much interested.
Yeah, that's good. They are happy with the session and they are feeling confident of using it. That is good.
Okay. Thank you, sir. Good night, sir.
Okay.